Let's look at some examples of different scatter plots and calculating the correlation coefficient. So when you're reading a scatter plot, you want to look for three things. The first is the form. So what shape is the relationship or the pattern you're seeing to the dots? If it's a straight line relationship or, pretty close, you can say that the variables are correlated. If there's a curved relationship, you can say they are associated. If there's no relationship, then you just say no relationship. And what that looks like is a random cloud of dots or no real pattern at all. Second is strength. If there is a relationship, how close are the dots to the overall pattern? You can say strong if it's extremely clear, there's little vertical scatter in the dots away from the pattern. And then moderate and weak would be, increasingly scattered away from that. The direction, correlations can be positive or negative. A straight line either goes up or down. A line that would be straight across horizontal, that's nothing. It's not doing anything. Associations, however, can be curved up. They could go down but level off. They can be U-shaped. They could be a sine curve. There's a lot of things that could look like. So if you put it together, you just have a sentence like, the scatter plot shows a moderate positive correlation between whatever the x variable is and whatever the y variable is. If you want to calculate the correlation coefficient, then you use the Excel command equals correl, C-O-R-R-E-L, select some of the values, comma, select the other values. So let's look at the next tab here, age and height. So these are the average heights of a group of children in an Egyptian village. So they got 161 children. Every month they measure the heights of these children. So 18-month-olds, the average height is 76.1 centimeters in this case, whereas for the 29-month-old children, they're 83.5 centimeters. So to make a scatter plot in Excel, the easy way to do it is put the horizontal axis variable in the left column and put the vertical axis in the y column. So if we just select those and go insert scatter plot like so, then we get something that looks like this, and we can say something like age versus height. And then let's add axis titles as usual, and age, months, and height, centimeters. And then again, we can clean up some of this extra white space here just by double clicking a number on the axis. And then we go over here, the minimum instead of 0, let's set that to 16 maybe, or 17 is fine. It doesn't really matter, but that looks a little better. We're using the space a little more efficiently. So what does this scatter plot show? So this scatter plot shows a strong, or you could even say very strong correlation between age and height of the children in this village. I'm saying very strong because you can see these are all very close to a line. In fact, if we add a line here, you can see the dots match up with this line very closely. There's a little bit of vertical scatter around the line, but not very much. And in fact, if we calculate the correlation coefficient, so equals C-O-R-R-E-L, parentheses, select the ages, comma, select the heights, and parentheses, enter, 0.994. That's an extremely strong correlation, which just backs up our observation from the scatter plot. They should be giving you the same thing. When you calculate this, it shouldn't be widely different than what you see in the scatter plot. Let's look at the next tab. The next tab here is US crime data file. So what we have is a bunch of data for 47 US states in 1960, and it covers a lot of things. The ones we're going to look at are things like crime rate. We're going to try to predict crime rate using these other variables. And you can see a lot of these might make sense, like unemployment rates, spending on police, years of schooling, such as that. So there's so much data here that I just split it out separately. Here, to make the scatter plot easy to make, I copied and pasted the ages in the x variable, copied and pasted the crime rate for the y variable. Since we're trying to predict the crime rate, we want the crime rate to be the y variable to go on the y-axis. Now, if you look at the scatter plot, it looks like there's really no relationship here, which is a little surprising perhaps because most crimes, it turns out, are committed by young men aged 14 and 24. I don't know if that's the exact range, but it gives you an idea. So the higher that proportion of the population is, you might expect the crime rate to go up. But if you look at the scatter plot, it's really not showing any relationship. Kind of a weird scatter plot because you've got a possible outlier out here, but you know, that's what you get sometimes. If you actually calculate the correlation coefficient, you get negative 0.089. It's never exactly zero, but that's so close to zero that it backs up our observation. It seems like there's no relationship between the variables. The other thing we can look at is police spending versus crime rate. So once again, I just copied the police spending, copied and pasted the crime rate again on the y-axis because we're trying to predict crime rate. And if you look at this, it looks like there's a moderate positive correlation between spending on police and crime rate. The dots generally go up, but you notice one weird thing is they're pretty close to the line at this end, but then they kind of fan out as you get further away. Why is that? To be honest, I have no idea. But you get lots of weird stuff when you look at scatter plots. If you calculate the correlation coefficient, you get 0.667. So that kind of backs up, yeah, moderate positive correlation, as we see in the scatter plot. The only other thing to look at in this one is, does that seem strange to you? Each one of these dots is a state. States that spend more on the police per capita have higher crime rates. So are you saying that the more you spend on the police, the more people commit crimes? And the question is, or the answer is no, this is not what we call a causal relationship. Spending on police doesn't cause the crime rate to go up, they are simply correlated. That's something we talk about more in the next module, but now just be aware that correlations, scatter plots just show whether two things go together. It doesn't show that one thing causes another one to change. So that's probably enough for this video. In the next one, we'll just go through a few more examples in this same spreadsheet.